Last class, we spent the time working on finding a way to randomize our samples and gather data from people in a correct way to avoid bias. So we looked at those random things. And we've been looking at observational studies, but today we're going to jump into designed experiments, and we're going to see how to design an experiment to avoid bias and to really be able to say that what we're studying has some cause and effect relationship without a lurking variable or all of those biases and changes. So what we're going to do first is identify some potential problems from experiments. So it is going to require you to think critically about what's wrong with the scenarios if we're trying to say that there's cause and effect relationships in these studies. So letter A, it says Mr. Wilcox is trying out a new beard oil to make his beard grow faster for No Shave November. At the end of November, his beard is 3 inches longer. So he concludes, cause and effect, that since his beard grew 3 inches, the beard oil must work. What's wrong potentially with this experiment?
He didn't try before he put it on?
He didn't try before he put it on. There was no control in this study. There was no multiple levels of treatment. Because we're just assuming that the beard oil worked, we didn't have any what's called a control group. A control group, or at least 2 levels of treatment, right? Beard oil, a lot or a little, would have worked as well. But there's no control group, which is a group that doesn't get the treatment. I got it. I just wanted to finish writing that word down. There's no control group, which is a group that doesn't get the treatment to compare the growth to. So if we wanted to fix this study, we could try a month no oil to see how much the beard grew, and a month with oil to see if it grew more. That would have a control, aka 2 levels of treatment. We could also try a month where we do, a minimal amount of oil versus the recommended amount of oil to see if the level of oil used has a cause and effect relationship. But if we're just saying this works, we had no reason to determine that it wasn't just like he got a good month of gene growing hair things. I don't know. So we need to look for controls or multiple levels of treatments. Letter B, the track coach decided to offer track athletes 2 options for daily workouts: a rigorous strength building workout or a relaxed workout of mostly stretching. After 2 months, the athletes that chose the strength building workout were 11% faster, while the relaxed workout group was only 3% faster. What's wrong with this study? Because now we have 2 levels of treatment to compare, so we're good on that aspect, but what else is maybe wrong? There's going to be a lot of awkward silences today.
Yeah, it's coming.
It's coming. Let it cook. Okay. Say that again. We didn't track for that. But we did see faster than they were. So maybe something else. Let's think about this. If you, no matter what your ability level, were to join the track team today and the coach offered you these 2 levels of treatment, which one would you choose?
The more relaxed.
Okay. But what if you were like going to state for track? Which one would you choose? Okay, so we didn't control for the randomization of the people in the study. So theoretically, the students who were maybe more casually running track probably all chose the strengthening one. Are they going to be the ones that naturally work hard to begin with? And the people who maybe picked the strength building workout, maybe they were the ones who knew they were trying to get college paid for with track. So they're going to work harder anyways. So we didn't control and we didn't randomly assign people to the true treatment groups. So there could have been bias. When we're building a study, we have to make sure that we have a random assignment of the treatments for the people in the study, for the individuals in the study. If the track coach had decided of the 40 people who come to track practice to randomize who gets what, we might have had some of the state track athletes do the stretching one, or we might have had some of the casual walkers along the track do the strength building one. And it would have evened out our study to maybe actually see if it was natural ability / motivation, or if it was the strength building versus stretching routines. So we have to randomize our experiments. Let's look at letter C. On a recent test day, a statistic teacher wanted to determine if smart pills would improve grades. As students walked into class, they were randomly assigned a pill that said either smart pill or sugar pill on it. Test scores were significantly higher for the group of students that took the smart pill. These don't exist. These don't exist.
Placebo.
Okay, tell me more about that. He said placebo.
Like, so people that took the smart pill, they could have thought, oh, I'm going to be smart. So they naturally just did better than the people that did the sugar.
Exactly. If you were told you're given smart pills, it's kind of like that scene in Space Jam where they're all in the locker room trying to... The Michael Jordan juice. That was just water. Right? But then they drink it and they're like, I'm good at basketball. That's the same thing that's happening here. So to avoid this concept of the placebo effect, what we would do is we need to blind our study. We would say, since this study wasn't blinded. I spelled that word wrong. Let me try that again. No, hello, blinded. Tough. Since the study wasn't blinded, the ones, exactly like Xander said, the ones who took the smart pills might have had a huge confidence boost. Instead of this experiment, because they did have 2 levels of treatment, they did randomize, but because the pill said smart pill or sugar pill, the person taking it knew what they were getting and could have had more of a psychological effect on themselves than an actual effect physically from the pills themselves. So instead of labeling the pill when you walked in smart pill or sugar pill, if we were really trying to see if they help, they'd just be like, here, you either get one or you don't. So you don't know if you got one. Because then the people who got the sugar pill still had the psychological changes of I'm doing good. They're drinking Michael Jordan juice. Secret stuff. Does that make sense?
I would have drunk it too.
I would have drunk it too. So when we are designing experiments, we need to make sure we have some sort of control or treatment groups. We have to make sure we always are having a random assignment of our individuals in the study. And when possible, that the study is blinded, either single-blinded or double-blinded, and we will discuss what that means in just a little bit. So let's actually start looking at trying to design an experiment. Last year, a local high school offered an after-school SAT prep class that students could volunteer to take. 44 students took the course, then they took the SAT, and the average SAT score for this group was 1220. The average SAT score for all students who did not take the prep course was 1050. Was this, the way it's described, an observational study or designed experiment?
No.
Did we assign treatments? Or did we just observe what happened? We just observed what happened. The way it's designed right here, this is just an observational study. We let the people volunteer to take the class. We didn't interfere. We didn't assign them anything specific. This is just an observational study because they didn't assign students randomly to prep or no prep. If they had decided to treat students with either getting the prep or not getting the prep and randomizing it, controlling it, it becomes an experiment. If you're just looking at people who showed up voluntarily, that's an observational study. Quick review of some vocabulary. What is the population being studied here?
People that volunteered to take the course and people that did not.
So, and what does that mean our whole population is? Too big. Not people who take the SAT. More specifically, yes, say it again. The population is the students at our high school. Because we're applying our findings from the sample that we took and comparing it to the whole population to kind of see whether this affected the population. Which means that our experimental units are going to be the 44 students who did the prep course. More a bit of a review here. What is the explanatory variable? Maybe we start with the other one. What is the response variable? The scores. Our response variable is the SAT score. Is this SAT score something that is quantitative or qualitative? It's a score, right? So it's a number. It's quantitative. Okay, now what are we seeing if it has an effect or has some sort of causation or association since this is an observational study, on the SAT score? Whether they did the prep or not, correct? Yes, so taking the course. Is taking the prep course a qualitative or quantitative variable? I've heard both now. Is there a number involved? Or are you just asking somebody, did you do this? And they would respond with yes and no. Yes and no makes it a qualitative. I think I spelled that word wrong. Qualitative. There we go. So, okay. Observational study. Remember, in observational studies, we cannot say something caused something to happen. We can just say there's an association. So there's an association we think we see between these prep courses and higher SAT scores. Let's say the principal wants to actually design an experiment to be able to say that one thing causes the other. So they're offering the SAT prep in two formats, an online class or with a classroom teacher. The school wants to know which teaching method will yield higher SAT scores. 50 students have signed up to take some form of SAT prep class. 20 of them are seniors and 30 of them are juniors. Let's start by outlining what's called a completely randomized design experiment to compare the two treatments. In this experiment, our treatments are online class, in-person class. Because last year we saw there was an association between taking a prep class and higher scores. So now we're really trying to get in there and see if the type of course has some sort of causation. So what we're going to do to design our experiment, we're going to start with the 50 students who signed up to take our class. This is our sample size. And in a completely randomized design, we immediately are going to randomize these 50 individuals into our two treatment groups. So right here, when we break this apart, this requires randomization. Randomization is what we learned about last time. We can either do a flip of a coin to decide where they go. We can say choose 50 of them using a systematic way or a stratified way. All of these things. We randomize 25 students into one group and the other 25 students into another group. We just immediately randomize them. From there, the first group would get maybe the online class. That's their treatment. The second set of 25 would get the in-person class with the classroom teacher. They go through the treatment. Then once the treatment is over, we can come back and we can compare their SAT scores. Since we interfered and we manipulated the way that they got the class, we will be able to say that there is some sort of causation, cause and effect between the type of instruction a student got for SAT prep and their higher SAT scores. That again is called a completely randomized design. So you take the sample, immediately randomize it, assign the treatments, compare your data. But let's say of the 50 students that signed up for the prep course, 30 are juniors and 20 are seniors. So the principal is worried that when we randomly assign the two groups, all of the seniors would end up in one group. Would we then be able to decide that it was just our prep class that increased their scores? Why would this maybe be a problem if all of the seniors ended up in one group?
Well, the seniors, so don't they have like more like knowledge, I guess?
Yes, exactly. Theoretically, seniors would have more knowledge because seniors have taken more classes. As a junior, normally you're in the classes that are learning the concepts that are on the SAT, and as a senior, you've already learned the concepts that are on the SAT. So seniors have taken more classes, so that may have more knowledge, which could affect the scores. So let's say our principal wants us to design our experiment for this study, controlling for age, controlling for juniors and seniors. Instead of doing the completely randomized design, what we would do this time to control for this age, bless you, is a randomized block design. Randomized block design. They have two homogeneous groups, which means two groups that are put together by some similar thing. We are going to group them first in those blocks, and then we're going to randomize to our treatments. So what we would do to design this experiment is we would take the 50 students who signed up for the prep class. We would block them by age. So we would have the 30 juniors, and we would have the 20 seniors into our two blocks. From our two blocks where we know that they are similar, that's where we randomly assign them into two groups. So at this point, this is where we're going to randomize into two groups, where we will put 15 juniors into one group, 15 juniors into the other. We would put 10 seniors into one group and 10 seniors into the last group. Notice that at this point, this is where we have to employ the random assignment. Always has to have random assignment. We can block them first, but then there still has to be a random assignment. From here, then we can apply our treatment of either online class or in-person class, or online class and in-person class. Once they have gone through the treatment from our random groups, we can then come back all together and compare SAT scores. We would be able then to control for age. Did the actual treatment of online or in-person class affect your SAT scores? Because we controlled for whether it was just because all of the seniors ended up in the wrong group and they've had more knowledge because they've taken more class. This way that we're blocking this here is called a randomized block design. Block them first, then randomize, as opposed to the first one where we just like straight up randomized it. Valid, but maybe not as valid. Make sense? Okay, but now the principal's thinking about it and they're like, what if when we're doing this, all of the people with the top 15 GPAs get in the online one. Would that skew the data more than age? So what we have done this time is now we've gotten a list of the 50 students and their GPAs. And we can sort it for highest GPA to lowest GPA. How could we use this list of GPAs from highest to lowest to design an experiment that tries to control for GPA or natural ability beforehand? What could we do? So like you're saying split it how? Like top 25 and bottom 25 go online in person?
No.
Okay, tell me more then.
Like, okay, so the top 25 or whatever, you split that in half, and you put half online and
So
half in person.
Top 12 online, next 12 in person?
Well, they're all on the top, right? And then the lowest.
Yeah, I like what you're thinking. I like what you're thinking, but can we split it even smaller?
I don't know.
What if? Because that's the right idea. Where we're trying to split and make sure that there's the same number of high and low GPAs in each group. What if we paired up the number 1 GPA and the number 2 GPA? And we made sure between number 1 and number 2 that they were in opposite groups. So what we're going to do here is we're going to pair up number 1 and number 2, then number 3 and number 4, then number 5 and number 6, all the way down the list of GPAs. And we're going to randomly assign one of those pairs into each of the treatment types, ensuring that some of our high GPAs go to one and some of our low GPAs go to the other. This designed experiment, because we are pairing them up, is nicely called a matched pairs design. Love that for me. If you're pairing things up before you start, it's called a matched pair. Here's what our experiment might look like if we start to control for GPA. We would start with our 50 students. We would group them in pairs. So we'd have the number 1 GPA and the number 2 GPA. Then we would have number 3 GPA and we'd have the number 4 GPA. We go all the way down the list, until we got to the number 49 GPA and the number 50 GPA. So we've paired up like or similar performing students. And from here, from these tiny little blocks that we've matched them up, a matched pair, this is where we're going to randomly assign them into 2 groups. Now, since there's only 2 things, what's like the easiest way to randomly assign 2 things like this? I asked that question in a weird way. Think like at the beginning of a football game. What happens at the beginning of a football game? Coin toss, because we got to figure out who takes the kick, right? They have an equal chance of getting it, and it's random because of the coin toss, right? Okay. From here, we could do a coin toss. Coin toss? I said that backwards. I'm tough. Number 1, we decide that they go to the first group. So this is 1 student, and then this is the other student. We are assigning them into 2 groups from this pair. But we're doing this coin flip, we're doing this randomization for every single pairing. Because we don't always want to take the top GPA and put them in the online group, or the bottom GPA and put them in the online group. We want it to still be random. So we're still randomly assigning 1 student to each treatment. Then they get that treatment. They will go through the online or in-person class. Online, in-person class. or the online and in-person class? Once they've gone through the treatment, then we can compare SAT scores among our two groups, the online and in-person, to see which method of prep provided the highest boost to SAT scores. So this time we've controlled not for age, but we controlled for GPA. Next question is a discussion we're going to have. So you can write down a little notes to yourself. I'm not answering the question. I want to hear from you because there's not like a correct answer. There's correct responses and correct reasoning. In summary, which of the three designs would you think works best for this particular question of which method of giving this SAT prep course is the best? That's what we're trying to find, online and person. Take a second. I want you to think. I'm going to call on some people to respond, so be ready with an actual answer. Which of the three designs do you think works best and why? So you think the last one because it what? I just didn't hear you.
It controls for like more variables.
Controls for more variables. Well, we're just controlling GPA. Are you just saying because we have more control over the randomization?
Yeah, like instead of like, cause like for the second one, right? You can get like randomly, you can have like randomly like low GPAs and like one high person, and it can like skew the results a little bit.
Okay. So you're saying theoretically then that GPA you think matters more than age.
Because it's more similar.
Yeah.
Okay, say that. Tell me more.
Since it's matched, they'll be more similar to each other, and it'll be better.
They're more similar to each other in a matched pairs design. Yeah, so then we're able to maybe see if it's the score or the method of the class as opposed to what you naturally come with. Did anybody think that the randomized block design is better? Tell me more, Jackson. You're giving me a maybe.
Because like comparing GPA, you can't. Because like, what if the GPA is from like other work and stuff? Because what if they aren't good at tests? You can't say they're gonna do good on the SAT just because.
Their GPA is high. That's a good point. Is your GPA high and you're a bad test taker, or is your GPA low but you're a good test taker? That's a great point. Perhaps that way, doing it by randomized block, you're just controlling for age but not for ability to take tests. Good point, because GPA doesn't always reflect your ability to take a test. Anybody else have any more opinions? I hadn't thought of that, Jackson, so that was a really good idea. I'd like to hear from one more person before we go on. Tell me why there's less bias on the last one.
Because you're getting from not only the different ranges of like, obviously assuming you would have in that way, of the grade level, but of the GPA. So, because at the end of the day, if you're thinking about it through a certain lens, the grade level has nothing to do with your like the age. It's more like your ability intellectually.
Okay.
Because you're taking a test, right? Not, but I get what Jackson's saying. Like,
Yeah.
But it's sorted, so it's like you're putting it's equal, it's balanced.
Yeah.
So you have a higher probability of getting like a less bias.
So is there a way we could control, this is an off-script question, but I just thought of it. Is there a way we can control like a matched pairs design, but for maybe something that speaks more to what Jackson was talking about, but test-taking ability?
All the students would have the same GPA.
We could have people would have the same GPA, okay. I'm thinking like, let's assume that these are seniors. You've probably already taken your SAT before, right? Could we do something with their previous SAT scores?
Yeah.
What could we do?
Like take a note of it.
Like what? I just didn't, y'all know I can't hear in one ear, so you have to talk louder. What if we tried to make it a matched pairs design, but we just had, instead of GPAs, we had their previous SAT scores? Could we do something similar? Like rank their previous SAT scores from top to bottom and then do 1 and 2, 3 and 4, 5 and 6 in the same way like this matched pairs design? It would account for what Jackson was worried about of being a good student, bad test taker, because it is a test score to compare test scores to. So that's interesting. Hadn't thought of that. Great. I'm going to be thinking about that all day now. Great. Okay, so some vocabulary, and I know I haven't really gone over a lot of these with you when we've done previous notes, but I am today. Remember, when we're talking about an experiment, we're having to do some manipulation to the study and vary levels or types of the explanatory variable to see if it has an effect on the response variable. This is a good one to make sure you understand. When I'm talking about a treatment, I'm not talking about like a physical treatment like PT or a medical treatment like a drug. Any combination of values of the explanatory variables or factors in the experiment that is administered to the subjects is a treatment. So our type of course, online or in person, is a treatment. Doesn't necessarily have to sound like a medical treatment. The control group is what we had talked about in the very first study. It's a group to which no treatment is given. It serves as a baseline to compare it to other treatments, especially if you're just trying to see if one thing works. You just have to have a control group to be able to compare it to. Thank you. Now, we already talked about this one, but the placebo effect. The placebo effect happens when you give a fake treatment called the placebo, the sugar pill, if you will, that appears exactly like the real treatment, and it produces some measurable effect on the response variable. So you could give a placebo and it not work, and that means there is no placebo effect. But if I were to, without telling you whether you got the smart pill or the sugar pill, just give you one, and then the sugar pill had just as much of effect as the smart pill, that's called a placebo effect. It's a little bit of a psychological effect on the experiment itself. Now, we discussed blinding a little bit, but I want to go into a little bit more detail here. Blinding is when subjects and or experimenters are unaware of the treatment an experimental unit is receiving. It is great if we can have an experiment that is double blind. Double blind means that not only do you, the subject, not know which treatment you're getting, the person administering the treatment doesn't know which method you're getting either. Why would that be important? For it, one, to be single blind, so you or the subject doesn't know what they're getting, but why would the experimenter being blinded as well be good for your study? Unbiased, is that what you said? Keeps them unbiased? Because imagine this. Imagine you designed a drug that you think will make kids smarter at statistics, and you're pumped about it, and you're excited about it. And so when you hand someone the actual pill, they don't know what they're getting, but you're like, got this big cheesy smile on. You're like, good luck, everybody. They're probably going to be like, I think I got it. Versus if you handed somebody the placebo pill, you'll be like, here you go. There is some effect that the experimenter can have on the experiment if they're not careful. So what experimenters have done is called double blinding a study, which would mean I know that bag A has the sugar pill in it and bag B has the actual pill in it. And I'm going to have my experimenter, the one actually giving you the drug, just say I gave person 2 bag A. And so I'm in my notes going, okay, well, they got the placebo. Or like, oh, they got the real thing. So the people involved in the actual experiment don't know. It's called a double blind study. It is nice when experiments are double blinded. We want that if possible. The last 3 definitions here are the definitions of the 3 types of designs that we did today. Your completely randomized design, so just truly take your sample and randomize it. Your matched pairs design, where you match up things that are related in some way. Or the randomized block design, where we put 2 groups together based on some related characteristic like age or grade level. And then within each block, then we randomize it like we did for the completely random. Those are our 3 main ways that we can design an experiment. And I'm going to have you in your homework today work with those different types to make sure you understand how to build these types of experiments.